Enterprise Computing Preliminary Course Unit 2, Networking Systems and Social Computing. So, as the name suggests for this unit, we are taking a look at network systems and the infrastructure that kind of sets up different types of networks, whether it be local or through the internet. But with a focus on social computing, that of the social media and the fact that we are trying to encourage networks that bring people together, have interaction, and set up virtual communities for people to interact through online platforms. So you can see a bit of connection here to what was already learnt with Unit 1, but this unit gets a lot more technical and is probably contains the most terminology out of all three preliminary units. So there's a lot to learn here, and it leads to a very messy mind map. So let's see if we can follow along. The first area is that of the introduction to human-centric computing, that we are developing systems with individuals, humans in mind, and their efficiency to get on the system and engage in their work. So areas related to this is the effects of disruptive technology. So how when we have new technology being invented or improved communication, it changes everything. It changes how we work. It means we can do work in different ways. So it has that effect on individuals in both a personal and work related manner. The innovations push change. So when a new technology comes out, it means new systems can be built with this new technology. And based on trends and what people are using, that becomes kind of new foundations for what systems need to include in order to support users, in order to make systems human centric for them. The next area is that of graph and network theory, and in particular in relation to social networking. So, with that in social networking, the graph theory relates to different users, pages, and groups that they might be accessing and tries to map that out and portray a kind of picture of what users go to what pages and what kinds of groups do they set up and all that. So, it kind of displays that in graph theory. And then from there is the network theory, which shows the flow of information through all these elements. All right, so they're the two theories in place there, and trying to map that out in social media. Obviously, it's very important in social media, if you, in particular if you're a platform, for managing the success of getting users, getting them interested, and allowing for people to grow and information to go through to expand their brands, okay, for specific users. The next area then is the influence on apps on social networking. As with social networking and outside of social networking, apps build on functionality. So when we include an app on within social networking, it expands what we can do. Whether it can be we can embed a game into the social media platform, or it could be a new element that can be allow for creativity and that can be shared through social networking. So the apps build upon this, and probably the easiest way you can see that is through your phone. Every time you download a new app onto your phone, you have a new function, something you can do. Okay, but we're talking about this in a social media platform type of way where you can share that element with your networks and the people who you've been set up with through your social media. The next area here is then hardware and software's influence on the IoT and IOME. Those two acronyms stand for the Internet of Things, which relates to all the information available on the internet that we can access and view, and then the IOME, the Internet of Me, things out there on the internet about myself. So there's a lot of categories related to this, specifically the impact on the individual with this data that is out there, as well as the impact on enterprises. We develop an identity and a reputation online, okay, whether it be ourselves or our business. What we do, there's info out there, and that will influence how people see us or our business. Now, the other side of this too is what's going on in the background. The hardware infrastructure that allows us to connect with these networks. So, what technology is running behind the scenes, and that will come up a bit later in this unit. Okay, and the software protocols that need to be used, okay, for specific types of communication, whether it be through accessing websites, accessing social media, accessing email. There are protocols in place so that all the different types of technology that are being used to access the networks, mobile devices, computers, game consoles, are all still speaking the same language when online together. Data obviously needs to be backed up, because if something happens to a particular server on a network, data could potentially be lost, and we still want that data. So we need backup, making secondary copies of data, in place to protect data, whether that means storing it offline or storing it at a different server in a secondary location. Okay, just that it's somewhere else so that if anything happens to our primary source, we can get it again. And then obviously things need to in place with regulation, compliance, and cybersecurity. And cybersecurity is actually the third unit of enterprise computing's preliminary course. Okay, but the fact that things are set up to make sure that businesses are bound by some sort of rules for their ethical use as well as the protection of data. And then finally, characteristics related to the startup and success of startup groups. Okay, people want to start businesses online and we want to create systems that people want to use. There are platforms available out there that give people the tools they need to have a network without having all the network infrastructure ready. They can start it from their home and connect to their website of the actual platform, giving them network capabilities, the chance to find users for their businesses and allow their brands to grow. Whether it be through some sort of specific platform or through social media, they can share their ideas, they can share their business and find customers. The next area of this unit is of storage and workflow in enterprise systems. And here we're going through a lot of the technical components. So that are the benefits and limitations of digital workflows. So data is digital, so we can share it quite easily. Okay, through a variety of platforms and through obviously making posts online. Okay, but then obviously there's limitations too and potential consequences too in the areas of protecting our data, protecting our ownership of data that we need to be mindful of and obviously think where we're going to be sharing our data. We then got developments in network connectivity, and obviously a lot has happened in recent years where we can do a lot of our work that traditionally we need to go into our workplace for from home. So obviously that first point there is of remote working. We can use video conferencing software to have meetings now, and then after those meetings, we can do our work at home. Okay, and still have all my team members' faces on screen so we can still speak as if we're in the same office. Another layer to this is of file sharing. There are now cloud platforms such as Dropbox, iCloud, and even Microsoft too have their OneDrive, okay, where multiple users can access shared drives online and be working on the same documents in those drives, okay, to collaboratively develop their work depending on whatever their workplace is. Okay, these items are set up once again to allow users to work remotely. And then obviously tools that support workflows with task delegation, who's going to be doing what. So we do have our, once again, face-to-face through video conferencing, but then we've also got specific items and apps that can be downloaded where we can share schedules through calendars and allow people to know when things will take place because we aren't in the workplace together, we are at home, we are off site, that communication still needs to take place. So that can be automatically logged into calendars so people know when things are going to happen. Okay, but obviously these things all support the changing nature of work, that moving away from the workplace and now more so working from home, which is a bargaining chip people now use when going for jobs that they want to work from home X amount of days per week. The next area is data storage requirements. Okay, and look, it's twofold. It depends if we're going to be storing our data locally, okay, in our own drives, but more so these days online. So what capacity do we need, okay, of storage? Do I need 1 terabyte of online storage or more to support all my business's data? We've got to think of that capacity there. And then accessibility. How will users access the data stored on our cloud platform or on our local platform? And then based on login procedures, what data within our storage can each user access to? Because we've also got to protect privacy and factor in not all users within my enterprise need to have access to all work. Okay, but then also on the other side of that too, through making it accessible, the fact that people who might have impairments or disabilities, okay, all of that is kind of broken right down because they don't have to travel into the workplace anymore. So having our data stored on a network drive supports accessibility because people can just be sitting at a computer at home and getting to the data they need quite easily. We've got to think of the location of where this data is going to be stored. It's going to be logical. So in the cloud, that's usually self-managed by the platform we're using. But locally, how is it a centralized drive? Is it going to be a single centralized drive, or maybe a distributed model if we've got a larger enterprise? And then obviously, as alluded to with accessibility, security measures that are going to be put in place. And we'll get to that in a bit later within this unit too, in order to protect data, ensure that the users viewing the data have a reason and right to be viewing that data as per their task. The next area is of cloud computing services. And really, it is what is the foundations of the services. So whether it be infrastructure as service, which is IaaS, software as service, SaaS, and platform as service. These all help set up our cloud services in how we're going to use them, how people will access them, okay, when we want to use these. And then we've got the different types of cloud-based data storage. And it basically relates to how it's going to be used and the restrictions in place. So will it just be a public cloud where anyone can access and share data and work on information? Is it going to be a private cloud, which is more of an intranet where actual users need to log in and be specifically a part of an organization, okay, to view the data within the cloud? And then in these days, most of these cloud services may be hybrid. We can have general customers coming in and viewing our data through our sites, but there is a portion within our cloud that is restricted to only authenticated users, and only they can access it to do their work. And then we also have non-cloud on premises, okay, where we don't use cloud technology. It's pretty much just the data we've stored on local hard drives there. So cloud technology can be used in a variety of ways to support our business based on what we are doing. Okay, the third area then relates to network architecture and infrastructure. Now we're getting into the technical nitty gritty of the actual networking systems. So the key components of IT required: the network technologies, hubs, switch, routers, gateways, bridges, all of that. Okay, the on-premise stuff we need in order to connect to the internet or to our customers. Okay, what infrastructure do we need? Is it just a router that is connected to our phone line or NBN that gets us to that network connection we need? Or are we managing a lot of the network ourselves from our business's location? And then how does that connect us to cloud computing? This is supported by transmission media. Okay, and I already said NBN just before. What is connecting our devices together, both locally and through the internet, to get to our data that is online? So our wired mediums of twisted pair Ethernet, our coaxial cabling, and then obviously optical fiber, which is the main infrastructure in Australia now, okay, within the roads of the NBN. And then our wireless mediums too, our microwaves, our satellites and radio signals that allow for wider area communication without the need for wires, okay? And obviously expanding upon the data in order to connect to services that are a lot further away without needing a physical connection. The next area is the transmission interference. We are using these mediums, but what can affect our data while being transmitted? So things such as distance between the nodes that are communicating between each other, and the topography, how specific nodes and mediums are laid out on a network. Okay, the mountain ranges, the height and the valleys, all of that will impact on how the data is sent. So there are physical and environmental barriers that will also include too. So just physical barriers could be transmitting high above a cliff, or trees being in the way, or specific buildings that have been built, okay, that data needs to be transmitted through. Okay, unfortunately, landscapes aren't all flat. We have houses, we have nature, all of that is impacting on the actual data being sent between our devices through our transmission mediums. And that obviously needs to be factored into our network infrastructure. Okay, we want to improve the data flow in the sense. So based on what we just said about interference, we need to think of our antenna power, our actual traffic filtering by how many users are accessing our network, and then how is that being dispersed among our technology that we're using on our network to support that flow and give users a good experience interacting and getting to the data they need and getting it back to them as information. And then things that can support that is flow scheduling and traffic monitoring, which obviously a network administrator needs to use. But we are also talking about smart systems too, and we have AI supporting this as well, that is monitoring this and then moving users down different pathways to support their work on a network. Okay, once again, we're talking about graph and network theory, but how can we optimize this for users? Okay, so we said that social media needs this stuff, but we want to optimize it if our enterprise is going to maximize its success. So the adjacency and centrality of the actual network, How are people getting to the data they want? How is that information flowing and being shared through the actual graph theory? Okay, and how it's all set up. How does it give users that feeling of connectedness to their data? Okay, and allowing them to expand through their social networks. And then what are the things that actually weighted on these graphs? Okay, so obviously an area that needs to be optimized for an enterprise to maximize their success. Okay, and then we've got to talk about specific devices that support the Internet of Things. So once again, getting users onto the internet and knowing specific protocols, HTTP, HTTPS, that incorporates SSL, SMTP, all of that that is required to access certain systems and services online. Okay, we then talk about machine learning, ML, in conjunction with the Internet of Things. As I said before, with managing networks, a lot of these are run by smart AI systems that will help map users on a network through specific routes of mediums and devices to control the flow of a network for their user experience on the network so they don't get too much lag or get dropped off an actual platform. Okay, ML, the machine learning, is data driven. So it will read numbers of traffic and bits per second and bottlenecking and bandwidth and all of that and try to control this traffic. Okay, it will report any types of diagnoses going place on the network and then try to respond to this. At this stage, we still want a physical human network administrator there to support the AI managing it with its machine learning. Okay, but a key area here is automation. These types of tasks are being taken over by AI because it is numbers based. They can make the diagnostic decisions and respond to them, okay? And they can operate 24 hours where humans traditionally can't. So we're developing smart systems to allow these network systems to function for users all over the world and control the flows of traffic, okay? We then, and as mentioned before, need to focus on network access and security. Now, we already know that we need logins and passwords to get onto the internet, and that controls users, allowing them to identify who they are and what network rights they have to access information. Okay, and that obviously passwords involves you typing in a string of characters, but then these are also replaced with things such as biometrics. Okay, and you see it on your phone. Your phone these days, you used to have to put in a PIN code, and you still do sometimes, but it can also just do facial recognitions. Facial recognition, thumbprint recognition, that's biometrics. It's reading your biology in order to gain access into a system. We also have a thing known as captcha. Okay, and that captcha that's used for detecting bots. That's when you log into a website with your password, then you might get a prompt come on screen of an image, and it might say, "What does this word say?" And it might be in a more calligraphy style of writing with a graininess behind it. And robots can't read that because it's not in an OCR type of character that they can read off screen. So only humans can interpret that, and it keeps the bots out. Okay. Same when you've got to click on the different squares on screen saying where is the traffic lights or where are the mountains. Okay. Robots can't distinguish that from a multiple panel of images, but humans can. So it ensures that only humans are getting into the system. And then what also might be on our systems too is that TPM, the Trusted Platform Modules, which is a chip that is used to support security measures. So support the booting of systems, making sure they are booting in a secure location, as well as checking the signatures of users, their digital signatures that are coming from trusted locations. Okay, TPM supports that. And then finally, software updates. And you guys are updating software on your mobile phones and on your computers. Software updates don't just update for compatibility and efficiency. They also update for security. Okay, so when you update your software, it could be new protections are being put in place on your systems through the OS to protect you from malicious software and unauthorized users because they've picked up a pattern, and then obviously platforms are trying to defend their users from this, and they'll push that stuff out through software updates. And then we've got the use of intelligent home networks. Okay, and we've seen things such as Alexa, where we can speak out loud commands and things will happen in our home. Switching lights on and off, the ability to check your mobile phone to see internal security cameras with your house. So these internal intelligent home networks that are being established where digital data is allowing us to do a lot of things from centralized devices, from our mobile phone, from our computers, and we can control functions within our house. Wow, we're living in the future now, aren't we? Okay, so the final area of this unit is creating a basic network. Okay, so obviously a lot of the creativity here is happening in this portion of the unit. So we want to design and model a network. We are setting up some sort of network, okay, and it mightn't be fully physical. We're designing it. We're designing its logic. What nodes are we using to connect what devices, and illustrating what mediums are we using to connect it all together. We are going to apply project management tools in order to do this. Okay, so what tools can we use? So the use of hardware and software to illustrate this here and map it out and how we're going to set up our network there. Okay, we got to have a bit of knowledge on how to configure network devices, and that can be embedded into an assessment. So the logical naming of specific devices, and then later on updating these devices with their naming, with their properties and what they're connecting with, how to configure specific protocols on a network, and configuring our actual devices for connection to the internet. So that stuff is potentially accessible within this unit in relation to the preliminary course and your knowledge in enterprise computing. Okay, also the implementation of security protocols that we just mentioned before, the setting up of passwords, the setting up of potentially biometrics if you've got cameras enabled and all of that, what things need to be done in order to protect users on a network. So a working knowledge of how to do that. We want to be able to optimize performance on a network. So knowing how to improve a bandwidth. So mapping out the routing of pathways on a network, the actual mediums we are using, okay, to distribute data. So as we know, optic fiber is the best wide medium, but it's expensive. The actual nodes that are at our central nodes. So our routers and switches that might be centralized, how have we placed them out on a network, and how's network traffic mapped through that. All of that helps improve bandwidth, but then also the other side of it too of updating drivers and firmware. Okay, so pushing out updates to our devices, which manufacturers do for phones and computers all the time. Okay, allowing the actual software to be updated so it can continue to be optimized and compatible with new technology out there. And then the final area of this unit, okay, evaluating the transmission IT. Okay, how good is it? Can it be improved? How can we evaluate the IT? So looking at when data is unsecured, what can we do about it there to ensure that it gets secured? The use of encryption, the ability to scramble data prior to transmission so that when it is transmitted, okay, if it does get intercepted, it won't make sense, it can't be read, but ensuring that when the user gets it at their end, they have the appropriate decryption key, okay, to translate that data back into readable form. Okay, so that comes along with it so they can interpret the data there. And then finally, just ensuring that our infrastructure is set up in a way that is logical and allows for data to flow through our network logically and efficient. So I hope this video has given you an understanding of the network systems and social computing unit of the enterprise computing preliminary course. It is the most technologically heavy topic in relation to understanding content. There is a lot here, and as you can see with this mind map, it's a big mess. But it is all terminology. So learning this terminology here and understanding the relationship between terminology will allow you to be successful in understanding this unit. Okay, and remember, we're not just learning about network technology and infrastructure, but how it is used to support social networking. Okay, the fact that it allows for the efficient interaction between different users globally in many cases with these enterprise systems to allow them to share ideas and have a pleasant online experience through their technology, so no lag, and they can get to the data they want and it loads quickly, okay, based on the efficient setup of these network systems.